So we are going to start, and let's first start by reading the directions. Find the missing side length of the triangles. Leave answers in exact forms, and we're going to be using 30, 60, 90, 45, 45, 90, or Pythagorean theorem. So I'm looking at this triangle, and I see that it is a 30, 60, 90 triangle. So the first thing I'm going to do is I'm going to draw my reference triangle. And again, this is the 30, 60, 90 triangle that we've been working with. Remember, it is half of an isosceles triangle. We said if this side is 2, then this side is 1, because again, it's cut in half. And then we did Pythagorean's theorem to figure out that this was the square root of 3. Next thing we did was we started to highlight the similar sides, if you will. Okay, and then we write our proportions from there. So we have our similar sides. So we're going to do this pink side over this pink side. And then we're going to do, I'm just going to call it the purple side, and I'll call this X. The purple side over the purple side. We're going to go ahead and cross multiply. Okay, and then we're going to divide by 2. So X is equal to 6. So the missing side that says X is equal to 6. The blue side I'm going to call Y. And we're going to go ahead and set up our proportions as well. So the pink side over the pink side is equal to the blue side over the blue side. Okay, and we're going to go ahead and cross multiply. So we get 12 root 3 is equal to 2y. And again, we're just going to divide by 2. Okay, we can do 12 divided by 2, and we get 6 root 3 is equal to y. So the side that says y is equal to 6 root 3. Now again, some of you guys are using scale factors, and you guys just know that to get from 2 to 12, you multiply by 6. So you would do the same for each of these. So 1 times 6 gives you 6, and 6 times root 3 gives you 6 root 3. Okay, that's using scale factors. I understand it's really easy. Some of you guys do it, but you can't always use scale factors. So I'm teaching you guys how to use proportions as well. With B, we're going to be working with a 45, 45, 90 triangle. This is an isosceles right triangle. So as soon as I see an isosceles right triangle, I know that it's 45, 45, 90. And it is 1, 1, and root 2. And so the legs are actually the same here, and the hypotenuse is a little different. So right away we know the legs are the same. So because this leg right here is 3, I know that this leg has to be 3. That's what those tick marks denote, is that those are congruent to each other. And we're going to call this hypotenuse X. So we're going to set up the purple leg over the purple leg equals the green hypotenuse over the green hypotenuse. And we're going to go ahead and cross multiply. 3 root 2 equals 1 times x is just x, so nice and easy for this one. And our x value is 3 root 2. Again, I know that by seeing that the scale factor is times 3, some of you already know that this is 3 root 2. Beautiful. That's what we want to get you guys in the habit of, is trying to do this quickly. And for my last one, I'm not going to draw any reference triangle because I see it's not a 30, 60, 90. I can rule that out. I don't see any angle measures. Therefore, it's not a 45, 45, 90. So I'm just going to use Pythagorean's theorem. I see it's a right triangle, which we want it to be a right triangle if we're using Pythagorean's theorem. So I'm going to label my leg, and my hypotenuse. And it's leg squared plus leg squared equals hypotenuse squared. 9 plus 16 equals hypotenuse squared, 25. To undo squaring, we square root both sides. So my hypotenuse is equal to 5. My next slide here. With the first one, again, I don't see any angle measures, so we have to do Pythagorean's theorem. I'm noticing that this one looks really similar to the last one that I just did. So keep in mind that these sides are 3, 4, and 5. And these sides right here are 6, 8, And I feel like I can kind of know what's going to happen, but we'll see. So leg squared plus leg squared equals the hypotenuse squared, and the hypotenuse is the longest side across from the right angle. So 36 plus 64 equals h squared. 100 equals h squared. And my answer is 10, which I thought it was going to be. Because again, this other right triangle, looking at this, these sides were 3, 4, 5. And now these sides are 6, 8, 10. So interesting. For E, I'm going to draw my reference triangle again. And again, it's half of an isosceles triangle. Not an isosceles. Yes, isosceles. Losing my mind. So we have our 30, 60, 90 triangle. And we are going to put our 2, our 1, and our root 3 side. And again, you have to match them up with the angles that are across from them. So the 2 always goes across from my right angle. That's always my hypotenuse. And the 1 always goes across from my 30-degree angle. And then the crazy middle child, my 60-degree angle, the root 3 is always across. So from here, you match up the sides. I like to use different colors to match up the sides just so I can write my proportion accordingly. And so I also put in variables immediately. So you guys are going to see that I'm going to call this just x and this y. And we're going to go ahead and write our proportions. And again, some of you guys are already using scale factors. You know how to get from 1 to 10. So you kind of already know what the answer is, which is awesome. I'm just going to show you with setting up proportions. So the blue side, the top blue over the bottom blue equals the top purple over the bottom purple. And we cross multiply, and we're done. And then we're going to do the top green over the bottom green equals the top purple over the bottom purple. We're going to cross multiply. 1 times x is just x. And 10 root 3. Okay, so once again, I know that some of you guys already identified this. To get from 1 to 10, you multiply by 10. Therefore, to get from the green to the green, you had to multiply by 10, which makes this 10 times the square root of 3. And also 2 to y, you multiply by 10, which gives you 20. And we found those same answers down here. Okay, so let's go ahead and look at this one. So I don't see any angle measure, so I'm going to go ahead and do Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. 25 plus 144 equals h squared. 169 equals h squared. And take the square root of both sides to get my h equal to 13. So I see 5, 12, and 13 for this problem. Okay, last 3 problems. Now these look like some really big numbers, but I'm also seeing this almost looks identical to the one that I did on page 1, right? So that first one I did on page 1 was 3, 4, and 5. And I'm looking at this problem, and this is 3,000, 4,000, and I feel like I kind of know what this is. So you're going to do 3,000 squared plus 4,000 squared equals hypotenuse squared. And when you actually go through and do this, you will get that the hypotenuse is 5,000. And we're going to talk more about this and why it is that this happens. Let's take a look at H. Okay. So once again, I don't see any angle measures. So when you don't see any angle measures, you're going to do Pythagorean theorem. So we are going to do leg squared plus leg squared equals hypotenuse squared. We've been looking for the hypotenuse this whole time. So 225 plus 36 times 36, I got my calculator, 1,296 equals h squared plus 225. So 1,521 equals h squared. And then we're going to go ahead and we are going to take the square root of 1,521. And you guys should be coming along with me, practicing on your calculators yourself. So h is equal to 39. And I feel like we saw this one previously as well. I think we had a 5, 12, 13 one, if I recall. And again, we're going to be referring back to these as well. And I see this one. Oh, this is good. Again, no 45, 45, 90, no 30, 60, 90. So leg squared plus leg squared equals hypotenuse squared. 25 plus b squared equals 169. Minus 25 minus 25. B squared is equal to 144 square root. And I'm getting b is 12. Oh, I feel like we've seen the 5, 12, 13 before. I believe on page 2 was a 5, 12, 13, except I had to find the hypotenuse. So it's almost the same exact problem on slide 3 for h and I. They look very similar to each other. For h, these look like multiples of the same number. So like 13 times 3. So this one just looks like it's 3 times larger. 5 times 3 gives me 15, and 12 times 3 gives me 36. So these are similar triangles by side, side, side. And again, we'll be referring more to these.